Okay, so before we start working with rational expressions, a lot of times it's good to just think back to how you actually work with fractions, because all the rules are going to be the same, right? So like here we see a addition and a subtraction. We know, hopefully, that if you need to do addition or subtraction of two fractions, you have to have a common denominator. Right? Once you have that, you add them, the denominator stays the same, you simplify the numerator. Here we have a division problem. Now division and multiplication, you don't need common denominators, but to multiply, you do numerator times numerator, denominator times denominator. To do division, we do copy, change, flip, or you multiply by the reciprocal, and you flip the second thing. So let's just kind of review that, make sure we're good to go here. For the first one, we have 7/2 plus 1/6. Now obviously we have two different denominators here. Right, so what we're going to do is we're going to take the two denominators and find the common multiple. Right? Now you could do 12 times 6 and you'd get 72, which is a common multiple, but we'd rather use the least common multiple. It makes our arithmetic easier. And you're going to be doing these by hand, so you want to use small numbers if you can. So in this case, we know that 6 goes into 12, right? 12 is a common multiple of both of these numbers. So we'll just leave 7 over 12 the same. And then the 1/6, we're just going to multiply it by 2 over 2. Right? This is an expression. We can't change its value. We can't change how much the number's worth, right, or its value. So all you can really multiply it by is 1. So when we do that, 2 over 2 is just a form of 1. You get 7/12 plus 2/12. Now at this point, they have a common denominator. We go ahead and add the numerator. So to do that, you do 7 plus 2 over 12, which gives you 9/12. And then we should always make sure to reduce, right? 9 and 12, 3 go into both of those. So we're going to get 3/4 for that one. Does that work? It should look familiar, I hope. That's the goal. The next one we have here is 3/4 divided by 4/5. Okay, today we're going to see what are called complex fractions. This is kind of the same idea here. If you have a fraction divided by a fraction, we don't actually have an algorithm to do division with fractions, so instead we just switch it to multiplication. So we're going to leave the first value the same, the 3/4. We're going to change division to multiplication, and we're going to take the reciprocal of the second number. Right? So the same, so copy, change, flip is I think how people usually say that, but you're multiplying by the reciprocal. So you flip it. So we do this, and we get 15 over 16. Doesn't reduce, so we're all done. Okay, last up here, we have 2/7 minus 1/2. Okay, so here's a subtraction problem. It's going to behave just like multiplication, or I'm sorry, addition, except we're going to subtract. So we look at our two denominators. We have 7 and 2. It's a common multiple of 7 and 2. 14, yeah, 14. So to make this 7 into a 14, I'll need to multiply it by 2. Right? Whatever we do to the numerator, we do to the denominator. So 2/7 times 2 over 2. For the second term, we'll multiply by 7 over 7. And then we'll get 4 over 14 minus 7 over 14. Okay, now once you have the same denominator, you're going to keep it through, until maybe you get to the end. But to combine them, you're going to keep that same denominator. I always think that you go to all the trouble to get it, it gets to stick around for a while. So with this one, 4 minus 7 over 14, and that would be negative 3 over 14. So is that working okay for us? Okay, so today we want to look at addition and subtraction and a little bit of division, all the operations of rational expressions. Okay, so these are things we've seen before. We just really want to make sure we're, kind of doing things the most efficient way and keeping track of things that way. So as we look at this one, we have 6 over 10v plus 2 plus 6v over 3. Now with this one, like a lot of them, if it factors, I would factor especially the denominators first. because we want to find that least common denominator. We talked about on the one warm-up where the common denominator was 12, but you could have used 72. It wouldn't have been that much harder. The numbers would have been bigger, but it would have reduced at the end. If when we have variables and when we have rational expressions, if you goof up and get if your common denominator is not the least common denominator, but some bigger degree, it might make a polynomial that you can't factor in the numerator. Like it can cause kind of significant issues for you. So really important to look at your denominators and factor those. So as we look here on this left hand, we could take out a 2. And then here on the right, we have 6v divided by 3. Does that simplify? Sure, it's just 2v, isn't it? Now, we're going to need to get a common denominator with it. If that seems weird, you could write it as 2v over 1, which helps sometimes when you're dealing with all the fractions. That's just a nice kind of gateway thing. So if you wanted to do that, because we know we have fractions, that's fine too. But as we look, our least common denominator, well, here also, we have a 6 and a 2, don't we? Because in this term, all of the addition and subtraction is hidden inside a parenthesis. We can go ahead and reduce the outside part. So we can reduce this one to become 3 over 5v plus 1, and then plus 2v plus 1. So again, don't overlook that we can sometimes simplify ahead of time. It'll make our lives easier as we move forward. So then from here, our least common denominator is going to be 5v plus 1, right? Because this is just 1. Everything's common with 1. So we'll write 3, 5v plus 1 plus 2v times 5v plus 1 over 5v plus 1. Again, we just multiplied on top and bottom. I didn't bother writing 1 times 5v plus 1 because it seemed kind of unnecessary, right? They're the same number. So at this point, now we have two fractions added together, and they have the same denominator. Okay, so that's all the way back to what we were looking at in the warm-up. One of your main addition rules says a over b plus c over b equals a plus c over b. If the denominators match, you can just add or subtract the numerators. So here we're going to say 3 plus 2v, 5v plus 1 over 5v plus 1, right? Whatever that common denominator was. We go ahead and leave it here. But now here, be careful. We're almost done. We've done all the hard work in terms of getting a common denominator and all that. But there's some mistakes that people make, and usually they have to do with order of operations. Okay, so if we look at this numerator, it needs to be simplified because I see this plus out here, right? And that plus out in the open also tells me I can't do any canceling right now. So it would be wrong to cross any factors off that match. I can't. I have to get the top expanded, possibly factored, before we can do anything else like that. So with this numerator, you have a few different operations. You have parentheses, but you can't do anything inside them. The 2v is being multiplied by the parentheses, and then this is being added. So it tells us we do our multiplication first because of our order of operations. Don't be tempted to, not that you would probably do 3 plus 2v anyways, but sometimes if they're both just constants, it can be tricky. So 3 plus 10v squared plus 2v over 5v plus 1. Again, I just distributed the 2v. And did I change a minus sign? No, it's been plus the whole time, hasn't it? Oh, okay. On your paper, I guess it was a minus sign the whole time, wasn't it? Whoops. We'll just call this another example. We'll let you try that one on your own. So just to be careful there. So as we look at this now, here I'm just going to go ahead and just put this back in standard form. So 10v squared plus 2v plus 3 over 5v plus 1. I guess it's not going to work. But there's a potential that you could factor the numerator, but there's not two numbers that multiply to be 30 and add to be 2. So we're done. So This was not on your worksheet. This was a different problem because I copied down the wrong sign. But still a good problem, right? Still look at it, still take a look at that. So that's an example of how just old addition of rationals. Okay, so I'll leave that. So let's go ahead then, and we have one more we want to look at here. And this is from the back of the worksheet, and I'll actually make sure this is correct this time. It's a squared over a minus 2 minus 4 over a minus 2, 1/2 plus, this is number 11 from your worksheet. Sorry about that last one. I'll let you see how it would change it. I think all that would change is the one negative sign gets distributed. Now with this one, this is called a complex or compound fraction. It's got fractions within fractions. You don't ever want to give an answer that has fractions inside of fractions. Bunch of ways to do this. There are some shortcuts which are pretty nice. What I would recommend we do though, starting off, is just get the top to be a single fraction, get the bottom to be a single fraction. All right, once we have a fraction divided by a fraction, it's just like the division problem we did in the warm-up. It's just going to be copy, change, flip. So with this case, now as I look at this, is the numerator already, like the numerator already has a common denominator, correct? So for the numerator, it really just depends. Maybe here I'll write them both kind of out, but the numerator will become a squared minus 4 over a minus 2. Right? Is that good as we subtract these together? Now, do you notice this top does factor? Right, it'll become a plus 2, a minus 2 over a minus 2. Then we have a factor that cancels out, don't we? So let's cancel that. But I'm still going to maybe write that as a plus 2 over 1, because I'm going to need to use that as a fraction here when I deal with the whole fraction together. So that the denominator is 1/2 plus a minus 2 over 4. So as I look here, the common denominator would be 4. So I'm going to multiply this left hand by 2 over 2. So that's 2 over 4 plus a minus 2 over 4, which you get 2 plus a minus 2 over 4, and you get a over 4. So what we have here is we've converted the numerator into a single fraction and the denominator into a single fraction. So that means this is equivalent to saying a plus 2 over 1 divided by a over 4. Again, keep the big long fraction bar, just to remind you that is the big division symbol, and the other ones are just fractions in the numerator, fractions in the denominator. And then to really step through this process, this is the same as a plus 2 over 1 divided by a over 4. Right? The big fraction bar means division. And then from here, we can copy, change, flip. A plus 2 over 1 times 4 over a. Then we'll multiply the numerator, so that's 4. A plus 2, the denominator would just be a. Now I like it like this. I like to leave the numerator factored, but if you just said 4a plus 8, it's fine also. And there's no canceling that can go on. There's no more factoring. So we're done. Okay, is that looking okay for us? Okay, so